Okay, third part, Black-Scholes option valuation. So Black and Scholes, the two scholars built actually the option valuation models. The formula is this one. Looks complicated actually. So first of all, S0 is the price as of today of extension function of negative delta. Delta is the dividend yield. Okay. And T is the time to expiration. And ND1 is the cumulative normal distribution of the D1, which is this one. So we'll see that later. Minus X is the exercise price. Times exponential function of, now R is usually risk-free rate. The interest rate. Negative R times T, which is X times expiration, and also ND2 is the cumulative normal distribution of the D2. So I'm not going to prove this model because it's too complicated. It requires very complicated mathematics skills. Usually even master's program does not prove it. Only very computational mathematical masters prove it after learning stochastic process and a bunch of other probability statistics course. So for this class, we are not going to prove it, but we just want to know how to plug number into this formula so that we can get the value of the call and put option. Okay. So first of all, remember, not really memorize, but remember where this formula is, looks like. And then the next slide, we'll see the example here. So you can use the Black-Scholes model from fairly easily because you just plug the number into the formula. It looks complicated, but once you plug in, then number pops up. So suppose the stock price is 100, exercise price is 95, interest rate is 10%, dividend yield is 0, and the time to expiration is quarter year, so 0.25, and the standard deviation is 50%. Okay, I mean you can download the Excel spreadsheet actually to solve these problems on Moodle. So I'm going to actually use this Excel spreadsheet to explain. You have different numbers, but we can actually change the numbers here. So standard deviation is 0.5, expiration is the 0.25, risk-free rate is 10%, stock price is $100, and exercise price is 95, and dividend yield is 0. As you know, we have to calculate, you have to get the D1 first, D1 and D2 first, right? So if you go back to the slide, D1 is, let's look at this. Log of S0 divided by X, exercise price, plus R, interest rate minus dividend yield, plus the variance divided by 2 times T divided by volatility, the standard deviation times square root of T, right? So again, go to Excel spreadsheet. We already set a formula here, but basically it's the same as. So if you look at that, it's a S0, right? Divided by X. And all the formula is actually from this. So it's a D1. And D2 is simply D1 minus the sigma times square root of the T. I'm sorry. So with this, now what we have to do is we need to get D1 and D2 and plug ND1 and ND2 here, right? And this ND1, ND2 may be found here, this table I don't recommend you to use table because for this class, I mean, probably have to find this sometime, but most of the case we use Excel. So go to Excel spreadsheet again, and we have 0.4302D1 and 0.1802D2, and there is a formula called a norm as dist. Okay, so norm as dist of D1 and norm as dist of D2 is basically what it means. Is basically this. So D1, D2 means this is D, okay, and ND1, ND is this one. So usually the for column option D1 is greater than D2. So usually D1 is this one, and D2 is, so in this case we have 0.4 something, right? This is called the standard normal distribution. Standard normal distribution is a distribution, normal distribution with zero mean, and so average is 0 and the standard deviation is 1. That's called the standard normal distribution. And this is like D that we calculated here. So with our calculation, I believe the D is the 0.43 something, right? And our Excel spreadsheet actually show more details. 0.4302. So we can use this one. This is actually 0.4302. And this probability, this shaded area, will be ND1. And 0.1802 is like this, right? So like this less area is like the ND2. So that's what we want to know. Okay. So go back to the spreadsheet. We can use simply norm as this DIST, which is the cumulative normal distribution of the standard normal distribution actually of this D1 and D2, and the D1 is 66.65% and D2 is 57.15%. We calculate it, right? And then what we need to is, now we need to again go to the formula, and now we have D1 and D2, right? And we need to have S0 times this exponential function, X times this exponential function. Again, we can plug here everything like this. This is the Black-Scholes of the call value, $13.69, actually 70 cents. So we can easily use this formula, like the Excel formula, to get the Black-Scholes values. Okay. So, I mean, I don't really, I mean, as long as you understand this model, not really understand, but I mean, as long as you know this model, I suggest you plug the number like this, or like Excel, mostly Excel, get the answer, because the answer is exactly the same here, right? And I just want you to know how to plug number into the formula. That's all you need to do for this class, first of all, right? So this is all the one. Now, Black-Scholes formula can be used in practice fairly, I mean, many people, most people use the Black-Scholes formula as a fair value of the option valuation. Now, you have market value, obviously, because option is traded, right? So option trading market value, and you have other variables, and you can actually calculate the volatility using the valuation model. So it means that, again, using these formulas, there's volatilities here, right? We can solve for this formula for volatility. Again, we probably cannot manually do this job, right? So we have to use Excel to do this job. Okay. So let's go back to the slide again, and let's do this job. So this is 16.4 figure. Suppose the time to expiration is 0.5. Risk-free rate is like 0.06. And the stock price is 100. Okay. And exercise price is 105 and no dividend yields. Now, suppose call option value is $7. What is the standard deviation? So it means that we don't have standard deviation. We don't know. But we know call value because in the market, the option is trading, right? So we have market value and we believe this is good value, fair value. Then you can actually calculate, we can calculate the price of, the standard deviation from this model. So this is called implied volatility. To get it, you have to find a goal seek. So I personally use the Mac version of Excel. So if you use Excel, the Mac version, there's a tools. I believe the Windows version probably similar. And there's goal seek. Click goal seek. And now we set this cell, right? Equals to 7. So we know that the value of this option is 7. And we want to know these values, okay? Then it actually calculates the implied volatility. Solve for this equation, basically. 0.2783 will be the standard deviation. If the call price is like $10, what about the standard deviation? Then you calculate that 0.3847. It should be higher, right? Because as standard deviation gets increased, then your call value increased, right? So that's how to use the Excel goal seek function, goal seek tool actually to get the implied volatility. So again, you have to know how to find implied volatility. Now, this is implied volatility of the S&P 500. And if we believe implied volatility is right, then option is usually fairly priced, right? That's what it means. And from 1990 to 220, about 15, this implied volatility is very consistent with the volatility of the market itself, which means our implied volatility is trustable, which means our Black-Scholes model is trustable. This call value is from the Black-Scholes model. The market value of the option is close to the fair value from the Black-Scholes model. So this is one way, again, to generate to prove kinds of to find the evidence of the validity of the Black-Scholes model too.